Hello, we are back today with more factoring. Today the method we're going to be using is called factoring by grouping. An indicator that you're going to use factoring by grouping is if you see that your polynomial has 4 terms, exactly 4 terms. If that's the case, then what you can do is group your terms. So on this example A, I'm going to group my first 2 terms together, and then I'm going to group my second 2 terms together. And from each of these groups, I'm going to factor out the GCF. So let's look between 2x cubed and 8x squared. With my coefficients, my greatest common factor is 2. And with my shared variable, my lowest power is x squared. So I'm going to be able to factor out 2x squared, and my leftovers go inside the parentheses. So on my first term, I have x left over, and on the second term, I have 4. So if I factor out 2x squared, I'm left with x plus 4. And again, you can check to make sure you've done this correctly by distributing what you factored, and you should end up with what you started with. Now let's look at my second group. Between 3x and 12, I can only factor out a constant, and my common factor there is 3. And if I factor out a 3, my leftovers is x plus 4. So now looking at each group that I've individually factored, I now have the common factor x plus 4, which I can take out from both terms. And that leaves me with 2x squared from the first term and 3 from my second term. So this is my final factored answer, and I can check to make sure I've done this correctly by foiling and seeing that I end up with what I started with. All right, let's practice this again. B. I have 4 terms, so I'm going to group the first 2 and the last 2. Y cubed plus 5y squared. I don't have a common factor for my coefficients, but my lowest power for my common variable is y squared. That leaves me with y plus 5 left over. On my second set, I can just factor out a 7, and that leaves me with y plus 5. So y plus 5 is now a common factor that I can take out, and my leftovers are y squared plus 7. Again, FOIL to make sure you've done this correctly. On C, group, 8n cubed plus 56n squared. I'm going to be able to factor out an 8n squared, and that leaves me with leftovers n plus 7. On the second set, I can factor out a 3. That leaves me with n plus 7. n plus 7 is now a common factor. My leftovers are 8n squared plus 3, and there is my final factored solution. Okay, on to D. I don't know why I said 10. My first 2 terms, I can factor out 10v squared. That'll leave me with 3v plus 2. And on my second term, I can factor out a 5, and that leaves me with 4v. Excuse me, that would be 5v, not 4. 5v plus 4. Now, what I have factored, the inside leftovers does not match. So I cannot factor this any further. This is done. We can't do what we've done on A, B, and C because these don't match. So that's it. That's as much as we can do. On to E. Again, I'm going to group and group. 48x cubed minus 6x squared. I can factor out 6x squared, and my leftovers will be 8x minus 1. Negative 384x plus 48. I can factor out a negative 48, and that will leave me with 8x minus 1. So 8x minus 1 is a common factor, so I can pull that out, and I'm left with 6x squared minus 48. There is my final answer. Again, FOIL, double check that you've done it correctly. Last one, group. I can take 15y squared out of my first 2 terms. That leaves me with y minus 5. And I can factor out 35 from my second group, and that'll leave me with y minus 5. So take out y minus 5. It's now a common factor. 15y squared plus 35 is my final solution. Again, all of these you can double check that you've done correctly by foiling and verify that it is the same polynomial that you started with. And that's it for today's notes.